Once you check whether you are able to see the screen. ಕಾಣಿಸ್ತಿದೆನಾ?
Yes, ma'am.
Okay. Okay, first we'll solve the simple problems where these problems will be asking for only for 4 marks, or else sometimes 2 marks also they may ask. The first problem here, it is of a point charge. It is Q, that is it is having 0.4 nanocoulombs, is located at the origin. And what it is located at origin, what you have to do for this, obtain the absolute potential of A, that is where it is located is of 2 comma 2 comma 3, x y z coordinate are taken as a 3, these things. The solution is going to be the potential of A of this we are going to be considering due to a point charge Q at the origin. Therefore, we know this equation, that is VA is going to be equals to, for this point location we will be finding point, we will be finding, for that reason here it is written as VA. Which point they are giving for us, that point you have to write here, that's it. That is going to be equals to Q divided by 4 pi epsilon naught into the distance what it is going to be covering, that is about RA, where our A is going to be 2 comma 2 comma 3 and the Q is at 0 comma 0 comma 0. What is the RA in the previous cases? Distance, how we have to find out, we already know in the first class. So the same thing, what you have to do, RA is going to be equals to square root of P1 minus P x1 minus x2 plus whole square plus x2 minus y2 whole square, then z1 minus z2 whole square, that you have to do. Therefore 2 minus 0 whole square plus 2 minus 0 whole square plus 3 minus 0 whole square, that's going to be equals to square root of 17 you will be getting. Then substitute in the equation, VA is going to be the charge, it's already given, that is 0.4 nanocoulombs 10 raised to minus 9 divided by 4 pi. It is a epsilon naught, the standard value you should know of this, 8.854 into 10 raised to minus 12 into square root of 17. Just you solve, you will be getting as the value 0.8719 volts. The reference here, it is in this case it is taken as n infinity, that's here it is written. Okay, next problem, the same point charge, instead of locating at origin, it's located at a different location, that is here it is taken as 2 comma 3 comma 3. Actually in the previous case that point charge it is at origin, but the point charge is shifted, or else it is located at a different position and A point is remaining same. Therefore A is 2 comma 2 comma 3 only, but Q is at 2 3 3. Observe here, this is our origin, our Q is located at 2 comma 3 comma 3 and our A is located at here, that is 2 comma 2 comma 3. What is the distance in between of these? From O to A, here it is taken as R, and from O to Q it is R dash. I want the distance between the point charge and to the point, that is A. What is the distance you will be getting? R minus R dash you will be getting, that is RA is going to be equals to R minus R dash of the model. Therefore the distance is going to be square root of, this is our RA, 2 minus 2 whole square plus 2 minus 3, 2 minus 3 whole square, then 3 minus 3 whole square. If you solve for this, you will be getting as 1 only. The equation remains same, that is VA is going to be equals to Q divided by 4 pi epsilon naught into RA only. Just the distance is changed here. Therefore, just you substitute the instead of RA in the previous case, everything will remain same. Only thing is our RA will be changing. The value what we got is of 1, that you have to substitute. Then everything remains same. Just you calculate for that. Then you will be getting as 3.595 volts. This is what the value you will be getting of. Next, in the same way, if the point B at minus 2 comma 3 comma 3 in the same example, obtain a potential difference between A and B, here it is asked. If I want the potential difference of 2 points, we already know that VAB is going to be equals to VA minus VB. Okay, Then VA, VB are the absolute potentials of A and B, where VA we already calculated in the previous case, that's 3.595 we got. Then we want what is the RB, means the equation is going to be, instead of RA here it is going to be changing as RB. Therefore, what is RB is going to be, where is our B point of this point, and where is our A, it is of 2 comma 2 comma 3. Therefore, minus 2 comma minus 2 of minus 2 will be getting as minus 2 of minus 2, then 3, sorry, not, you should consider at for K, the B point is somewhere here, okay. We want the point charge is at here. We want the what is the distance of in between of these. What is the B value here? Minus 2 comma 3 comma 3. What is the distance between of these? Minus 2 of minus 2, then 3 of minus 3, again 3 minus of 3, you'll be getting up 0 0 only, then you'll be getting the distance as 4. Then find out what is VB, that is equals to our Q divided by 4 pi epsilon naught into RB, that is 4. Then substitute the value, then you'll be getting the as 0.8987 volts. Then what you have to do, VAB is, we know that VA minus VB, then subtract of these two, then you'll be getting as 2.6962 volts. This is how we have to calculate. Next, if three charges, that is 3 microcoulombs, 4 and 5 microcoulombs are located at different locations here, 0 0 0 and 2 minus 1 3 and also 0 4 minus 2 respectively. Find the potential, where it is asked that you have to consider 1 comma 0 comma 1 and assuming a 0 potential at infinity. Okay, this is a Q1 charge, that is here it's taken as 3, Q2 as minus 4, then about Q3 as 5 coulombs. Observe here, the point is at, the A point is at 1 comma 0 comma 1, then Q1 is here, where is location is of 0 0 0, then Q2 is at 2 minus 1 3, then Q3 is at Q3 0 4 and minus 2. Then first you have to find the with respect to A with the first charge, VA1 will consider of that, Q1 divided by 4 pi epsilon naught into R1. Then same steps you have to follow when you are going to find the resistance, that is R1 is going to be 1 minus 0, 0 minus 0, 1 minus 0, that is whole squares, and take the square root of that. Then you will be getting as square root of 2. Then substitute VA, 1 is going to be 3 into 10 raised to minus 6 divided by 4 pi epsilon naught into square root of 2. Then calculate for this, you will be getting as 19.0658 kilo volts. Next, due to point charge Q2, observe here, maybe here it may be minus, they may skip to here, okay, just to make that correction in this question. Then what is our VAT is going to be Q2 divided by 4 pi epsilon naught into R2. R2 is distance between of A and Q2, where it is 1 minus 2, 0 minus 1, 1 minus 3. Then take the square of those and take the square root, then you will be as square root of 6. VA2 is going to be equals to minus 4 into 10 raised to minus 6 divided by 4 pi epsilon naught into square root of 6. Calculate for this, you will be getting as minus 14.6769 kilo volts. Then same way you have to calculate for the Q3, same steps will remain same. Then go on substituting here, then you will be getting here the R3 you got as square root of 26, and VA3 just you substitute the charge, here it will be 5 and everything remains same, only distance will change again. Square root of 26 you will get. You will be getting as 8.8132 kilovolts. Then just what is the VA? What is the total potential across point A? What you have to do? We have to add all the three. When you add all the three, that is VA1, VA2 and VA3, you will be getting as 13.2021 kilovolts. This is what you will be getting the value. Okay. Next, the different problem. A point charge of 6 nanocoulombs is located at the origin in free space. Find the potential of a point P if P is located at 0.2, minus 0.4, 0.4, and here three conditions given. When V is at infinity, when potential is at 0 with the location as 1, 0, 0, and one more is V is going to be equals to 20 volts when at minus 0.5, 1, minus 1. This is what it is given for. The first case, if I am going to consider here, where our V is infinity, then Vp is going to be equals to, he just is substitution is given where the point we are going to locate, that's it. Vp is going to be equals to Q divided by 4 pi epsilon naught into Rp. Here the location is of our origin, that is a Q. The point is at minus 0.2, minus 0.4 and 0.4. Here is P is and Q is at origin and it is going to be infinite length. Then Rp is going to be. Then what is the distance between of these? Then we don't know where is the actually. It is in a infinity fashion, that's it. Therefore Rp is going to be 0.2 minus 0, then minus 0.4 minus 0, then 0.4 minus 0, each of the square and take the square root of that, then you will be getting as 0.6. Then you substitute in this equation, then you will be getting as Vp is going to be 6 into 10 raised to minus 9. It's all they only given, that is over 6 nanocoulombs. 6 into 10 raised to minus 9 divided by 4 pi 8 point, this is epsilon naught value, 8.854 into 10 raised to minus 12 into 10 raised to, into the distance 0.6. Just you calculate here, you will be getting as 89.8774 volts. Then the next case is here is a V is at 0 at 1, 0, 0. The reference is not at a infinity. Therefore, here the location is at, we have to take one more, that is about R point. The P point is at the same location what it is taken in the previous case. Here the R is at 1, 0, 0. Therefore, Q is at origin and R is at a reference is at R 1, 0, 0. Therefore, Vp is going to be equals to Q divided by 4 pi epsilon naught into Rp plus C have to consider in this case. Then Vr is at 1, 0, 0 is going to be a 0 value only, that is going to be equals to 0. Therefore, Vr is going to be equals to Q divided by 4 pi epsilon naught into R of with the distance of R this for this point, plus C is going to be equals to 0 only. What is the distance of the in between of these? Directly we can write, tell 1 minus of 0, 0, 0 and 0, it's 1 only. Just you substitute here, Vr is going to be equals to, Vr is already told it is of a 0. Therefore 0 is going to be equals to the Q value 6 into 10 raised to minus 9 divided by 4 pi epsilon naught value 8.854 into 10 raised to minus 12. Distance is of 1 plus the constant value, that is C. C is going to be equals to, now calculate for this, you will be getting as minus 53.9264. Then substitute for Vp, that is Q divided by 4 pi epsilon naught into Rp plus C. Here the distance, what is the Rp of this point? We already calculated that. In the problems, if the questions given in the same way, then you can directly write the answer. But if it is asked direct of this point only, then you have to calculate of this, then substitute here. Here it's already calculated, for that reason taking that value here directly, that's it. Q divided by 4 pi epsilon naught into Rp is going to be 89.8774 minus what the value you got in the previous case, 53.9264. Then you will be getting as 35.9509 volts. This is how you should calculate the values. Then this is with a reference at where it is of 1, 0, where voltage is given as 0 at this point. For that reason, here it is taken as 0. Next, here it is not at 0, it is at 20. In the second step, what we done, here we equated to 0, but you should not equate to 0 here. You have to equate it to 20 volts at the point minus 0.5, 1, minus 1. Let that point, it's not that you have to take M, R, S, whichever the character if you want to take, you can take. It's not that M only have to take anything, it's left to you, but when you're going to solve the problem, it should be in a correct fashion. Here it is taken as a M point for this consideration, that is located at minus 0.5, 1, minus 1. Then Vm is going to be at this, what is the potential? Vm is going to be equals to Q divided by 4 pi epsilon naught into Rm plus of constant. Then Vm is going to be equals to what? In this case, it is of, it's given, that is 20 volts. Then what is the Rm? That is equals to just minus 0.5 of, with respect to Q only will be going to find out. Therefore, directly I can write minus 0.5 square, 1 square, minus 1 square. Then we will bring as 1.5. Then Vm is of 20. That is going to be equals to 6 into 10 raised to minus 9 divided by 4 pi into 8.854 into 10 raised to minus 12 into 1.5 plus C. For now, you find out what is the value of C. Then Vp total of this point now we will be able to find, that is Vp is going to be equals to Q divided by 4 pi epsilon naught into Rp plus C. Here it is how we already know this value, 89.8774 minus 15.9509. You will be getting as 73.9264 volts. This is one problem. This is how you have to solve the problems when it is given with a different cases. Don't keep in your mind that the same variables will be given for you. The variables may change according to the problem. Okay, based on that you have to solve the problems. This is one type of problem. Next, here a small keynote is given. The distance of P from origin where the Q is located is taken as Rp, which will be same for all the cases what it is taken in the previous case. Only the charge changes as the reference changes with the Vp changing. That's what here it is telling. Next, these are all some formulas where you will be using for next problems where we are going for. The potential difference is going to be in terms of integral form. VAB is going to be minus B to A final to initial E dot dl. Then absolute potential in terms of point charge, it is Q divided by 4 pi epsilon naught into R. Whatever the problems we done in the previous case, it is for the point charge. Next, in terms of a line charge, rho L dl divided by 4 pi epsilon naught into R of V. Then about in a surface integral, instead of rho L, it's rho S into ds divided by 4 pi epsilon naught into R with the surface. Then due to volume charge, integration with respect to volume, rho V dV divided by 4 pi epsilon naught into C. Then if the reference is other than infinity, the cases in the previous case what it is, if it is not infinity, other than infinity, some other points are there, then you have to take VA as Q divided by 4 pi epsilon naught into R plus C. R is your distance for point VA here it is considered. You can take of VB anything based on the question what is given. Okay, these are all things about, these are the important equations for the potentials. Next problem, it is important where it is asked in the exam. A total charge of 40 divided by 3 nano coulombs is uniformly distributed over a circular ring of a radius, here it is given as 2 meters, placed in Z is going to be equals to zero plane with the center as origin. Find the electric potential at, what is the value it's given, 0 comma 0 comma 5. Observe here, x, y and z. xy is not there, means the both are 0, means only at the z location our point is existing. Just you observe the figure now. Where is our a point is now? It is in the z plane. If they asked you to find as a 0 5 0, means where it will be? It will be in the y. Yes, or else it may have 5 comma 0 0, means it will be in the x coordinate. In which coordinate the point is located, that you have to find out. Then this is what the location we find out. Then this is our circular ring, and what is the radius of this? It is of 2 meters. Then differential length is going to be of this part, and this is our p. This is a angle, it is of a pi in the pi direction. A ring, it is having z is going to be equals to 0 plane. And what is the distance of this? By using of Pythagoras theorem, we can write that r is going to be equals to square root of, what is the distance from this to this? From this only we can find out, it is of a z is going to equals to 5 only. Z square plus this is r dash, this plus r dash square. Therefore this is what the figure for the given question. Then what is the charge distributed over a ring? Hence it is of a line charge. Hence the line charge density is going to be rho L is equals to what? Total charge divided by circumference of the ring. You should know about these small equations, then it will be easy for you how to calculate. The rho L is going to be total charge divided by circumference of the ring, that is going to be equals to 40 divided by 3 into 10 raised to minus 9, that is your charge, divided by 2 pi r. That is equals to what? What is our r is here? It is of 2 only, 2 meters. Then for substitute in r as 2, then it will be getting as 1.061 nanocoulombs per meter. You will be getting. Then consider the differential length, that is here it is taken as dl on the ring at point P. Then dq is going to be equals to what? Rho L into d. This is the basic equation. We already taken many times when going for the theory part. We already know of this, that you are writing. But in this case, it's a dl is going to be equals to what? It is in a r into d pi, that is equals to r dash is going to be 2. The value is 2 into d pi in the xy plane. In the xy plane, but here the direction is towards the a pi, for that reason. Then dl is going to be equals to what? Dl into a pi. Hence dl is going to be equals to r a dash into d pi, that is nothing but 2 into d pi only you will be getting. Then what is our dq is going to be? Instead of dl, I can write here as rho l into 2 into d pi. Then what is differential in terms of potential? That is going to be equals to differential of q, that is q charge, divided by 4 pi epsilon naught into r. What is the r? We already know, that is the distance between of a and p points, that is equals to square root of r dash square plus z square, or if you change the, it will be the correct only. Therefore dVA is going to be equals to 2 into rho L into d pi, that is our dq, divided by 4 pi epsilon naught square root of 5 square plus 2 square. Then we will be putting as 2 rho L d pi divided by 4 pi epsilon naught square root of 229. Therefore VA is going to be equals to, when I am going to take differential to, if I want to change this, if I integrate with both sides, your differential will cancel off. Then you will be getting the, what is the VA value? That is going to be equals to line integral of L 2 rho L into d pi divided by 4 pi epsilon naught into square root of 29. What is the value here? The pi is going to be, it's a general way, that is 0 to 2 pi, it's going to existing. 2 into rho L into d pi divided by 4 pi epsilon naught into square root of 29. Just for pi is varying from 0 to 2 pi, then apply the limit here. Everything will remain same, nothing will be changing here. Rho L value Just going substituting here, then you'll be getting as 22.252 volts. This is what you'll be getting off. This is one problem. Next is of the same, almost the same. A total charge of 40 divided by 3. This 40 by 3 base you'll be getting as L only. Okay. Nanocoulombs is uniformly distributed over a circular disk of radius 2 meters. Find the potential at a point on axis of 5 meter from the plane of the disk. In this case, what is the note here it's going to be, we have to consider is that the charge distributed over an entire surface. In the previous case, it will be taken as a line integral, but here it is of a surface of the disk. So it is of a surface charge. Just remember which one you have to take, in which fashion you have to consider it. Okay, then it will be easy for us. Then what is the surface charge density? It is of rho s is going to be total charge divided by area, that is nothing but 40 by 3 divided by pi r square, that is going to be 40 divided by 3 divided by 4 pi into r square is here also the same. Almost all the data what's given it's the same, but it is of a surface integration. That is here it is going to be 2 square, then it will be as 1.061 nanocoulombs per meter square. Here also the disk is placed in the xy plane and z is in the axis shown. In the same cases what it taken in the previously, the same. The disk is placing here with the surface ds bar. Then here what's the changes are going to be? Consider the differential surface area ds at point P having a radial distance of r dash from the origin. Therefore, instead of dl what's taken in the previous case, it's here it is going to be taken as ds. That's going to be r dash dr into d pi. Therefore, the dq is going to be what? Rho s ds. ds is of what? R dash dr dash into d pi. Therefore, dva is going to be equals to d divided by q divided by 4 pi f log naught into r. Then substitute for dq here as in the previous case. Then find out the r. It's the same as previously what we taken. That you have to substitute here. Then dva is going to be equals to rho s r dash d pi divided by 4 pi f log naught into r square root of r dash square plus 25. Therefore, here observe here two variables will be coming here, r and d pi. Right? R will be varying from r is equals to 0 to 2 as 2 meters. It's a meter. It's written. Just you write as a 2. That will be enough. Then pi is from 0 to 2 pi. Then what here it is taken? R square plus 225. It's taken as u square. Therefore, if I go on solving for this, that is you will be getting as 2r dash into dr dash. It's going to be equals to 2u into du. The simple things you can know, you will be knowing by using of integration. What are the modification you can go with that. Then r dash is going to be equals to 0. Then our u is going to be 5. R dash is going to be equals to 2 and u is going to be equals to square root of 29. Based on the limit will be changing now. Then go on substituting here. Then solve for the integration. I hope you will be knowing how to solve this. If anyone don't know means I will share the in detail the calculation of this once. Okay. If anyone not knowing means then we'll go with that. That is going to be equals to rho s divided by 4 pi f log naught, where u is varying from 5 to square root of 29 and pi is varying from 0 to 29. Then substitute for the values here. Then you'll be getting as 23.0776 volts. This is how we have to solve the problem. Next, one more problem we'll take. The electric field intensity E is negative gradient of a scalar potential. Find E at point of P of 0, 1, 1 if the condition is of V is going to be equals to E naught e raised to minus x sine pi y divided by 4 in the Cartesian system. B is going to be equals to V E naught into r cos theta in the spherical system. First case, if I am going to consider, V is going to be equals to E naught e raised to minus x sine pi y divided by 4. What is the E is going to be? It is of minus del of V. That is nothing but minus of, because minus dou V divided by dou x ax plus dou V divided by dou y ay plus dou V divided by az dou z into az. Where in which case it is varying. In this case, y is going to be a constant and varying it with respect to x only. Therefore, dou v divided by dou x is going to be equals to e naught sine pi y divided by 4 minus of 1 e raised to minus x you will be getting of this part. E raised to minus x of anything means minus of that, what you will be getting of that. Then dou v by dou y is going to be x is a constant. Therefore, you will be getting as, instead of sine, you will be getting as cos. Right? Differentiation of sine is of cos. Therefore, e naught e raised to minus x is remains same. Instead of sine, cos pi y divided by 4. This is a constant value that you have to take pi by 4 on as it is. Then it's not the given equation. It's not varying with respect to z. Directly you can write as dou v divided by dou z is going to be equals to 0 only. Then you have to substitute for the dou v by dou x and dou v by dou y in the equation. That is our E. Minus of minus e naught e raised to minus x sine pi y divided by 4 into ax plus e naught e raised to minus x pi by 4 cos pi y divided by 4 into ay volts per meter. Where at point P 0, 1, 1, the value, if I substitute here, then you will be getting as E is going to be E naught times 0.0701 ax minus 0.555 ay volts per meter. Means you have to substitute for x as 0, y as 1 in this case. E raised to 0, then sine pi by 4 of 1 here, then here cos pi by 4, here sine x is e raised to 0 means 1. Yes, then you just you solve by calculation, you will be getting the values. That's it. Then B is given as, what is the next of? It is a V is going to be equals to E naught into r cos theta, where our what is the coordination system? It is for the spherical. Therefore, for spherical, what is the equation you will be getting? E is going to be minus del V. It's going to be minus dou V divided by dou r of AR plus 1 divided by r dou V divided by dou theta of A theta plus 1 divided by r sin theta dou v divided by dou pi of a pi. Then calculate for each and every factors here. Dou v by dou r is going to be equals to e naught cos theta. Then dou v by dou theta is going to be minus e naught r sin theta. Dou v by dou pi is going to be 0 because it's not varying. A simple differential. It's not any lengthiest one. Just go on observing. It will be easy only. Then total E you will be getting as what? Minus e naught cos theta AR plus e naught sin theta A naught A theta volts per meter. Then with the spherical coordination with the pointer. Here it is going to be r, theta and pi. Therefore, r is going to be equals to square root of x square plus y square plus z square. That is now going to be equals to what the value will be getting. That is square root of 2. Then pi is going to be what? Tan inverse of y divided by x, that is pi by 2. And what is the theta? Theta is going to be calculated by using of cos inverse of z by r, that is going to be equals to 45 degree. Then substitute in this equation, then E will be getting as plus E naught of minus 0.0701 AR plus 0.7071 of A theta volts per meter. Okay, we'll stop here. Next one we'll take in the next class. These are all the problems what we solved. It is just for 4 marks, and one problem which is asked in the question paper that may ask for 6 marks, and remaining part it is just like a you should know how to solve the problems. Next we'll go through somewhat lengthy problems where it is included with all things.